everyone. Let us try to solve this geometry problem. Now we are given four congruent equilateral triangles lined up together, and each triangle has an area of 6 units. We're going to find the area of the yellow triangles. Now as you can see, the area or the yellow triangles here actually has the same shape, only that they have different sizes. So that means we are going to use the concept of similarity. And when we talk about similarity, there is always what we call the constant of proportionality. And in order for us to be able to determine the constant of proportionality, there has to be a reference figure that is the source of that so-called ratio of proportionality. So that means there should be one figure that will be used in order for us to be able to compare the ratios of these three triangles because they are not joined together. So we need to join them or place them in one shape in order for us to establish a similarity ratio. And one way to do it is to draw a line connecting the four apex of the four original triangles. So now, since we want to establish the similarity ratio, we need a measure of one of the sides. But since we are not given the side measure of the triangles, then we can just label the side as S. And take note, the triangles are equilateral. That means they have equal sides. And since these three triangles that are inverted is just a mirror of all the four triangles that are given in the problem, then these also are equilateral. That means their sides are also measuring as units. Now, as you can see, the yellow triangles are now placed in one figure. So we can establish now the similarity ratio. So look at this big triangle here and this red triangle. As you can see, this one here, this blue triangle and this green triangle and this red triangle rather have the same shape, only different in sizes. So this is now similar. So we're going to find the measure of this side because this is one of the sides of the original yellow triangle. So we need to find the measure of this side. We establish now a similarity ratio. So in similar triangles, the corresponding sides are proportional. So this side here has to be proportional to the side it corresponds to it. So this one here corresponds to this one. So the ratio will be this over S. Another corresponding sides is this one and this entire segment. Now this one is 2S because this is S here and another S. So that's 2S. This one here is 3S because this is S, another S, and another S. So this will be this one over S is equals to 2S all over 3S. Now, if we solve that one algebraically, we can establish that the ratio is 2/3 S. Now, the same thing that we're going to do with the smallest triangle. We're going to solve for this side here because this is again a side of the yellow triangle, of a yellow triangle. So we establish the similarity ratio. This one over S will be equal to the ratio of this side here, which is S, over 3S. Solving that algebraically, we have 1/3 S. So we now have the side measures of the yellow triangles. Now, after this one, since the numerators are just 3, then we can simply rewrite S as 3 over 3S, just to establish or just to show that they have the same denominators. Now, remember that, again, in a similarity or in similar triangles, the corresponding sides are proportional. And since these sides here are corresponding, they form a proportion. That's 3 over 3 is to 2 is to 3 is to 1 over 3, or simply 3 is to 2 is to 1. And remember, when you talk about the similarity, we now have another theorem that mentions about the area in relation to the ratios of the sides. And it says the ratio of the areas of two similar triangles is equal to the square of the ratio of the corresponding sides. That means if we take the areas of these three yellow triangles to be T1, T2, and T3 respectively, then the ratio of these areas will be the square of the ratio of the corresponding sides. So that's why we will have T1 is to T2 is to T3 is equals to 3 is to 2 is to 1 squared. Or when we simplify that, that is T1 is to T2 is to T3 equals 9 is to 4 is to 1. And this is the ratio that we're going to use to establish the area of one of the triangles. Now, since we're talking about area, always remember that the area of a triangle is 1/2 base times height. So if this is your original triangle, since this is an equilateral triangle, then any of these sides could be your base. So if we take this side as the base, then we can draw the height like this. And as you notice, this one here is similar to this one. And aside from that, when we draw the height this way, the base will be divided into two segments. This segment here and this segment. This is also what happens to this one here. So since this is just similar to this one, so this is the height of this triangle here, and this height divides this base into two segments as well. Again, let's just label this aside as the sides as S because we don't have the measure of the sides and they are equilateral. So again, the S here will be divided into two. So let's now consider this triangle and this big triangle here because they are similar. We now establish a similarity ratio. Let's just label this one as X. So we'll solve for this one. So to solve for X, again, since these two are similar triangles, we establish the ratio X over S is equals to corresponding sides S over 1, 2, 3, 4S. Solve for X, then you have X over S equals 1/4, and that gives you X equals 1/4 S. Therefore, this is now 1/4 S. That means the base here is now divided into two parts. 1/4 S, that means 1/4 of the side, and this one. Since the entire length is S, and you already have 1/4 S, that means this side here that is left is taken when, or this side here results when we take 1/4 from S. That means this is just 3/4 X. So as you can see, the base now of the yellow triangle, of the big yellow triangle, it's just 3/4 of the base of the original triangle. That means we multiply the area now by 3/4, or we multiply the base now by 3/4 because the base is again just 3/4 of the original triangle. So since we multiply the base by 3/4, to maintain the equality, we also have to multiply the area by 3/4. So that is now 3/4 A is equals to 1/2 times 3/4 BH. We simplify that. That is 3/4 A is equals to T1. But take note that A is the area of one equilateral triangle. We are given that one, and that is 6. Therefore, we substitute it. 3/4 times 6 is equals to T1. Solving that, the area of triangle 1 is 9 over 2. Now, we use this ratio here to find the area of triangle 2. So we can have T1 is to T2 equals 9 over 4. So T1, T2, 9 over 4. So we have T1 is 9 over 2, so that is 9 over 2 over T2 is equals to 9 over 4. Simplify that, that becomes 1 over T2 is equals to 9 over 4 times 2 over 9. And simplify this further, you have 1 over T2 is equals to 1 half. Solving for T2, we have 2. Therefore, the area of triangle 2 is just equal to 2. For triangle 3, use the same concept. We can have T2 is to T3, which is 4 is to 1. That's why we have T2 over T3 equals 4 over 1. You have 2 over T3 because the area of triangle 2 is 2. So we just substitute it. Then simplify. You have 2 is equals to 4T3. The value of T3 is now equals to 1 half. So since we're going to solve for the area of the 3 yellow triangles, we have T1 plus T2 plus T3 equals 9 over 2 plus 2 plus 1 half. That gives you 7. This is our answer, and the problem is solved. So that's it for this video. Please don't forget to subscribe and like our channel for more challenging geometry problems. Thank you so much. Enjoy learning.